Hello, honors algebra students. Mr. Lawrence here with my gruff voice. And today we are going to talk about powers to powers. Now this should be very, very simple stuff. There is a shortcut, but I will not teach it to you. If you discover it, that would be wonderful. Let's talk about 2 to the third power. First of all, 2 to the third power means 2. Wait a minute, I wasn't supposed to do that. It means 2 times 2 times 2, which contrary to popular 8th grade belief is not 6. No, it is not. 2 times 2 times 2 is 8, of course, right? Or what happens when you have 2 squared to the third power? Well, there's 2 ways to think about it. I'm not going to tell you the shortcut way. You discover that. I may draw attention to it, but doesn't it mean 2 squared times 2 squared times 2 squared? Let me put my multiplication in. And as you all know, 2 squared is 4 times 4 times 4. And so this ends up being 64. I agree. Let me see something. 2 times 2 is 4, times another 2 is 8, times another 2, 16, times another 2 would be 32, and times another 2 would be 64. I find that very interesting. Let's see here. Let's see. 1, 2, 3, 4, 5, 6. Very interesting. Okay, let's go down to another example. And let's see here. All right, we have 4x squared. Well, that would be the same as 4x times 4x times 4x. And if you've been paying attention in class lately, you know that x times x times x will be an x cubed. Oh, silly me, silly Mr. Lawrence, excuse me. Let me change this exponent here to a 3. Silly me. Sorry about that. Okay, so x times x times x is x cubed. And 4 times 4 times 4 from the last problem is 64. That is very interesting. Look at this again. Let's see here. We got x cubed, and don't I have a 1 of an exponent here? Very interesting. I got that, and I have this. Ooh, I made green. How pretty. Okay, let's take a look at this one. We're going to have a 3x squared times a 3x squared times a 3x squared. I need my multiplication symbols. Well, 3 times 3 is 9. 9 times 3 is 27. Yes. And x squared times x squared times x squared would be x to the 6th. Do you see it? Do you see it? I'm not going to tell you. You figure it out. Okay. Let's do this one. Ooh, it's getting a little bit uglier. I would suggest, first of all, on this quantity of 5x to the 4th y cubed z, to put a little 1 in its place, right there. And I'm going to do it really quick. 5 cubed is 125. X to the 4th cubed is going to be x to the 12th. I wonder how I got 12. Y cubed is going to be y to the 9th. And then z to the 1st cubed will be z cubed. Are you catching on? If not, I will help you with it, but I think you're too smart for me to tell you. Now this one, you have 2 choices on how to handle this one. You could leave this negative exponent in, or you could rewrite the problem like this. Because remember, a negative exponent means to use the stairs or the reciprocal, and I will multiply it by itself. So 6 squared is 36. Y to the 4th squared is y to the 8th, because it means y to the 4th times y to the 4th. Z to the 5th squared would be z to the 10th. x cubed squared, x to the 6th. That is probably a very good way to do it. Okay, there's another way to do it, but if I do it that way, I will give away the secret. Oh, what the heck, I give away the secret. The secret is that when a power is raised to a power, you can multiply the powers. Look, I got 6 squared. I'll have x to the negative 6th, y to the 8th, 4 times 2 is 8, z to the 10th. Yes, and when I give a better answer, because I don't like negative exponents in my answer, 6 squared is 36. I need the reciprocal of him. He goes downstairs, becomes positive, y to the 8th, and z to the 10th. And look, I get the same exact answer. All right, one more example for you, and that will be the end of this video. This problem should be no different than the one I just did. We're going to do 7 cubed, and we're going to x to the 5 times 3 power, z to the 6 times 3 power, y to the 3 times 3 power, and w to the 7 times 3 power. All I did was apply this exponent to all of my other exponents. And if you want, I have a 1 there. So 7 cubed is 343. X to the 15th, z to the 18th, y to the 9th, that is a 9, and w to the 21st. And there you go. Of course, in all these problems, we're assuming any variable in the denominator does not equal 0. So in this one, y does not equal 0. W does not equal 0, right? Because you can't divide by 0. In this green one here, x would not equal 0. That is being assumed. All right, Mr. Lawrence signing off. Hopefully this is as easy for you as it is for me. We'll get some practice with this Tuesday in class. Good night, everybody.